Hello my dear students, we will continue with Newton's laws of motion, and today we will be doing Newton's third law of motion, under which we are going to first state the law statement, okay, then we will be learning Newton's third law of motion with simple examples, alright, then we will learn something about action and reaction. All right, then we will do a simple experiment. We will learn about an experiment demonstrating Newton's third law of motion. All right, so let's begin with the statement of Newton's third law of motion. Newton's third law of motion states that to every action there is always an equal and opposite reaction. So this is the statement. It states that to every action there is always an equal and opposite reaction. Now here we are learning about two terms, action and reaction. These are nothing but forces acting on objects, okay? So if an object is exerting a certain force on another object, then the another object will be exerting the same amount of force but in opposite direction to the first object. For example, you try to hit the wall, okay, your hands get hurt, okay, your hands are getting hurt because since you're applying a force on the wall is also applying same amount of force on your hand. That is why your hands are getting hurt, because of the force exerted by the wall on your hands. Okay, let us now elaborate on Newton's third law of motion, taking few examples. Okay, let us take example 1. We will take two magnets separated by a certain distance. So say we have magnet 1, say M1, having north and south poles here. Okay, let us take the simple case of attraction between opposite poles of two magnets. So here I will take north, the other side I will take south. This is magnet 2. Okay, so let us simply put 1 and 2, okay, as the names of the two magnets here. Now you keep the two magnets separated by a distance. Now without any effort they will start getting attracted towards each other. They get attracted, or they will start moving towards each other with a certain amount of acceleration. Where did this acceleration come from? We have already learned in the second law of motion, Newton's second law of motion, that if there is a force acting on a body, there is acceleration produced in the body. So acceleration, they are getting accelerated towards each other because there is a force acting on them. Okay, now say this is exerting a force F on the second magnet. Because of the first magnet, the suffix I will write as 21, don't read it as 21. Okay, so this denotes force on the second magnet because of the first magnet will be always equal to force on the first magnet because of the second magnet. Okay, and they will be opposite to each other. That means I can simply put a negative sign just to show that they are opposite to each other. Okay, now you know algebra, right? You take the things from the right hand side to the left hand side, the sign gets changed. Let's do that now. F21 minus will go that side with a plus sign. F12, now nothing remains here, so we will put as 0. Now this is giving you the value of net force in the system. Now what is the system comprising of? The system is comprising of two magnets separated by a certain distance. Okay, so this is an application of Newton's third law of motion, where one magnet is exerting a force on the second magnet, all right, and the second magnet is exerting the same amount of force on the first magnet as well. That is why they are getting attracted to each other with equal amount of force. All right, so and lastly we have seen that the net force acting on the system is equal to 0, because the two forces being equal and opposite in direction, they are just going to cancel out each other. All right, let us now take a second example, quite different situation. Okay, you take the earth and the sun, two heavenly bodies, okay, of two totally different masses. Okay, now you have the sun in the center of the solar system. This is the sun, and at a large distance we have the earth. Okay, and we know that the earth is getting attracted towards the sun due to the gravitational pull. This is the first force. So we can say that earth is experiencing a force because of the sun. All right, what about the earth now? Because we have taken a system of two objects, and Newton's law of motion states that if one object is exerting a force on the second object, the second object also has to exert the same amount of force on the first object. All right, now what happens? The sun is exerting a force on the earth. This is say F1. Okay, now the earth is also exerting the same amount of force on the sun. Say this is F2. Okay, it might seem very strange, but if the amount of force exerted by the sun on the earth is 1000 Newton, the earth will also exert a force equal to 1000 Newton on the sun. Okay, but this force will not be that much significant as it is significant on the earth because of the difference in masses. The sun is huge, the impact of the earth on the sun, that will not be that much. Okay, but it does not mean that the earth is exerting a smaller force on the sun. The forces are the same, but the impact of force will be different because of the masses. Okay, we have learned the impact of mass on objects, all right, in the second, in Newton's first law as well as the second law. So that mass has to be taken into consideration, but the amount of force exerted on the earth by the sun and on the sun by the earth will be the same. This is the example of second example of Newton's third law of motion. All right, we have other examples as well. Okay, I'll give you a simple day-to-day example. You have a table, okay, on which you have kept a book. Okay, now this book has got a certain weight that is acting downwards. So this is the weight of the book. According to Newton's third law of motion, book is exerting a force on the table that is its own weight. Now because of this table also has to exert same amount of force on the book also, and in opposite direction. So another force will be acting on the book. One force is acting on the table because of the book, another force is acting on the book because of the table. This is called reaction force. Okay, so also called normal reaction force. So weight of the book and normal reaction force is a pair of two forces acting on a system of book and a table. Okay, and these two forces will be exactly equal and opposite to each other because they are following Newton's third law of motion. Why only them? Everyone has to follow Newton's third law of motion. All right, now this weight of the book, if we call it action is a kind of force, okay, acting on one of the bodies in a system of two bodies, then normal reaction force will be called reaction. So action reaction are a pair of forces which follow Newton's third law of motion, and they are always equal and opposite in direction. So these are the three things you have to remember regarding action and reaction. These are a pair of forces, they are equal and they are opposite in direction. Okay, but one more thing, most important thing you should remember here is that action reaction, they act simultaneously, they are acting at the same time on two different objects. So action reaction never act on the same body, they act on two different bodies. Okay, so let me give you a list of the things you should remember, the characteristics of action reaction. So action reaction, what are they? Firstly, they are a pair of forces, they always come in pair. Okay, secondly, they are equal. Thirdly, they are opposite. Fourth point, they act simultaneously at the same time, so they are simultaneous forces. And fifth, they act on two different objects. Okay, this means if you take the example of the table and the book, action is being acted on the table and reaction is acting on the book because of the table. Okay, so these are the things you should remember regarding action and reaction, which is a consequence of Newton's third law of motion. So here we have a setup drawn on the board, experimental setup, where we take two spring balance. A spring balance is an instrument which is used to measure weight of a body. Okay, weight or force acting on a body. Here we will not be dealing with weight, we will be dealing with force. Okay, so we have got spring balance A and spring balance B. The name of the spring balances are A and B. They have been attached together with the help of a hook, with the help of two hooks. Okay, rings are being provided for pulling the spring balance to apply force on the spring balance. Now, and A, it is left free to for the pull. Okay, and spring balance B is attached to the wall with the help of a hook here. Okay, now what is to be done in this experiment is just the step involved is pull the ring. If you just pull the ring, that means you are applying a force. On which balance are we applying the force? We are applying the force on the spring balance A. Okay, now this will show some reading somewhere here. Okay, say the reading is, after pulling, say you applied a force of 4 kilogram force here on spring balance A. Alright, now without doing anything on the spring balance B, you will see that this will automatically show you a reading of, again here also reading will be equal to 4 kilogram force. Now we have not done anything to the spring balance B. How did this show some reading? It is because of the action of A on B. Alright, so here you will see that both the spring balances are going to show you the same reading, meaning the force acting on the two objects in our system will be the same. Okay, and the value here in the experiment is 4 kilogram force in each case. Now let the force, because action is acting on A, so which is producing a force on B, which is exerting a force on B. So force on B due to A is going to be our action. Okay, likewise this is exerting a force on A as well. So force on A due to B, which is equal and opposite to the force for kilogram force, this will be called reaction. All right. So the pull on the spring B by the spring A is the action. The pull on the spring B by the spring A is the action, and the pull on the spring A by the spring B is the reaction, that is FAB. And experimentally we have seen that these two are equal. That means action, reaction are equal and opposite to each other. Okay, this demonstrates that to every action there is an equal and opposite reaction. Okay, so their magnitudes are the same, numerical value is the same, but they are in opposite directions. So the net force acting on this entire system, like I told you, is going to be 0. All right, so this is how we can demonstrate Newton's third law of motion taking just two spring balances. All right, so we will stop here. Let me give you a brief revision of what we have done in today's class. Firstly, we stated Newton's third law of motion, which is to every action there is an equal and opposite reaction. Then we took some examples to be clear about Newton's third law of motion. We took two totally different situations. First, we took the situation where we had taken two magnets getting attracted towards each other because of action and reaction. Then we took the situation of the earth and the sun, where the force on these two were the same, but because of the difference in masses, the impact of force was not that much. All right. Then we learned what action and reaction are, what are the characteristics, property. We learned that action reaction is a pair of force. Then they act on two different objects. They are equal in magnitude but opposite in directions. They act simultaneously on two different bodies. Then lastly, we did the experimental demonstration of Newton's third law of motion taking two spring balances, where Newton's third law could be proved. All right. Then we have a few applications of Newton's third law of motion as well, like walking on the ground. We would not be able to walk on the ground without Newton's third law of motion. Okay, the reason, we exert a force on the ground will exert an opposite force on us, due to which we are able to walk smoothly on the ground. Okay, likewise pushing a wall, I gave you the example. You try to push a wall, you feel the force given to you by the wall. All right. Then when a boat moves in water, what happens? The boatman does not pull the water forward. He always pushes the water backward, so that the water gives a reaction in the opposite, that is in the forward direction, and the boat is able to move in the forward direction. All right. Rocket also, when a rocket is launched, a lot of fuel, a lot of gas, a lot of energy is taken down in the downward direction, which will give you a reaction which will push the rocket in the upward direction. That is also an example of an application of Newton's third law of motion. All right. So that is all for today's class. See you all in the next class.